Alright, so in this problem, I have a to the power of a is equal to a. So to solve this, the first thing I'm going to do is I'm going to take the ln on both sides. So now I have ln a to the power of a is equal to a. And if I have something in the form ln x to the power of y, I can move this exponent y to the front. So this can equal y times ln x. So in this case, I can move a to the front, so this is going to equal a times ln a, which is equal to a. Or sorry, which is equal to ln a, because I took ln a on both sides. Now, what I'm going to do is I'm going to subtract ln a on both sides. So now I have a times ln a minus ln a is equal to 0. And now if I factor out ln a, I get ln a times a minus 1 is equal to 0. So now this gives me two equations. I have ln a is equal to 0, and I also have a minus 1 is equal to 0. So for a minus 1 equals 0, all I have to do is add 1 on both sides, and I get a is equal to 1. Now for ln a equals 0, to get the value of this, I'm going to first take e to the power of both sides. So I get e to the power of ln a is equal to e to the power of 0. Now e and ln, these two cancel out, so now I get a is equal to e to the power of 0, which is 1. Well, I got a equals 1 again. So the actual thing, what I'm going to do, because there is another solution, is now instead of simply taking ln, I'm going to take ln of the absolute value on both sides. So now I have ln of the absolute value of a times a is equal to ln of the absolute value of a. Because remember over here, I only took the ln normally, but now this is the absolute value. So now when it comes over here, I'm not going to have ln of a normally, I'm going to have ln of the absolute value of a is equal to 0. And this means that a is going to equal 1 as well as negative 1. So these are my two solutions. Alright, so in this problem, I'm going to be proving that 3 plus 3 is equal to 5. So, to prove this, I'm going to first start with the statement 0 is equal to 0, which is obviously true because any number is equal to itself. Now, what I'm going to do is for my left-hand side here, my left-hand side 0, I'm going to rewrite this as 9 minus 9, which is obviously true. Any number minus itself is 0. However, for now, from my right-hand side, I'm not going to do the same thing. I'm going to instead write this as 15 minus 15. So this is obviously legal. 9 minus 9 is 0, 15 minus 15 is 0, so there are no issues there. Now, for my left-hand side, 9, this is the same thing as 3 squared. So I'm going to write this as 3 squared minus 3 squared. And for my right-hand side, 15, this is equal to 5 times 3. So I'm going to write this as 5 times 3 minus 5 times 3. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I have 3 squared minus 3 squared, and a in this case is 3, and b is the same thing as well, 3. So now I have 3 plus 3 times 3 minus 3 is equal to 5 times 3 minus 5 times 3. Now, if I have something in the form a times b minus a times b, this is the same thing as a times b minus b. So I have 5 times 3 minus 5 times 3, and if I factor out 5, I get 5 times 3 minus 3. So now I have 3 plus 3 times 3 minus 3 is equal to 5 times 3 minus 3. Now, if I divide both sides by 3 minus 3, these two cancel out, and I get 3 plus 3 is equal to 5, or 6 is equal to 5. And this is obviously wrong. Where the mistake is when I divided 3 minus 3 on both sides, because 3 minus 3 is 0. So this is technically dividing 0 by 0, which is not 1, but it has no defined value. So that's where this proof went wrong, and this is wrong. Alright, so in this problem, I have m to the power of 9 is equal to 13 to the power of m. So now the first thing I'm going to do is I'm going to take the natural log on both sides. So now I have ln m to the power of 9 is equal to ln 13 to the power of m. Now if I have something in the form ln a to the power of b, I can move this exponent b to the front. So this is going to equal b times ln a. So in this case, I have 9 times ln m is equal to m times ln 13. Now, if I divide both sides by 9m, these two cancel out, and these two cancel out. So now I have ln m over 9 is equal to ln 13 over 9. Now, I'm going to take 5 something in the form e to the power of ln x. This is equal to x. So now I'm going to change this to sorry, this is actually not 9, this is m. This is supposed to be m. So now I'm going to take e to the power of ln m on both sides. Or sorry, now m here, this is the same thing as e to the power of ln m, because remember, these two cancel out. So now I have this is equal to ln 13 over 9. And now this is the same thing as ln m times 1 over e to the power of ln m, which is equal to ln 13 over 9, which is the same thing as ln m times e to the power of negative ln m, which is equal to ln 13 over 9. Now, if I take the W-Lambert function of something in the form a times e to the power of a, this is equal to a. So, what I'm going to do is I'm going to multiply both sides by -1 first, because we want a and a over here to be the same. Right now this is negative ln m, and this is positive ln m. So if I multiply both sides by -1, I get negative ln m times e to the power of negative ln m is equal to negative ln 13 over 9. Now if I take the W-Lambert function on both sides, I get negative ln m is equal to w of negative ln 13 over 9. And now I'm going to take e to the power of both sides. So now I have e to the power of negative ln m is equal to w of negative ln 13 over 9. Now I can move this negative to the front. So now I have e to the power of ln m to the power of -1 is equal to w of negative ln 13 over 9. And now these two cancel out, so now I have 1 over m is equal to w of negative ln 13 over 9, meaning m is equal to 1 over w of negative ln 13 over 9. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of x is equal to 1 over x. Now 4, this is equal to 2 squared. So let's first replace 4 with 2 squared. We get 2 squared to the power of x is equal to 1 over x. Now, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, this is going to equal 2 to the power of 2 times x, which is equal to 2 to the power of 2x. So now we have 2 to the power of 2x is equal to 1 over x. Now what I'm going to do is I'm going to take the power of 1 over x on both sides. So we have 1 over x to the power of 1 over x is equal to 2 to the power of 2x to the power of 1 over x. And remember, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n, meaning 2 to the power of 2x to the power of 1 over x is going to equal 2 to the power of 2x times 1 over x. And 2x times 1 over x, well, the x's just simply cancel out, so this would just be 2 squared. So now we have 2 squared is equal to 1 over x to the power of 1 over x. And now if we have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, this means that 2 is equal to 1 over x. Now we have a simple equation here. I'm going to multiply both sides by x. So now we get 2x, 2x is equal to, these two x's cancel out, so 1. Now if I divide both sides by 2, these two cancel out, and I get x is equal to 1/2. So that's our answer.